Hi, this video segment is about linking in C and the different kinds of libraries. After this video lecture, we will be able to reach three main objectives. First, we will understand how a library works and why it is useful. Second, we will understand the difference between dynamic and static library and what are the advantages and disadvantages of each approach. Third, we'll understand how to link statically and dynamically with the GCC compiler by playing a little bit with the compiler flags. You can think a programming library as a container of objects, files that you can take and apply in your code. In many cases, libraries are compiled during the installation of the compiler. For instance, when the GCC compiler was installed, also the C standard library was compiled. In other cases, somebody else, like a system administrator, compiled the library and she share with you. In other cases, when the library is not available, you will have to compile it. There are two main families of libraries, static or dynamic. Why do you want to use libraries? The first reason is that you want to save some time in coding by reusing some code that somebody else has already written and is providing you in form of library. In some cases, really speed up the development of your code. However, to use a library requires the knowledge of the library itself, so you need to study the different functions that the library provides. The second reason why libraries are useful is that some code is repeatedly used by several different codes. In practice, every C code uses the C standard library. In fact, just to print to display, we use the function printf that is from the C standard library. So it sounds like a good idea to keep just one copy of the library and all the code use it. There are several libraries available. Among the most famous and most used ones, we have the C standard library, that is a collection of built-in functions for using the I/O system. We saw before function from std.io, like printf, and also mathematical function from math.h. A second example is the glib library that provides the most common data structures like hash map and linked list. A third example is the new scientific library called GSL that provides a series of mathematical and numerical functions. One way to add the library to the code you are developing is to link the library object file and link time before running the code. This is called static linking. In this example, we have different codes producing object file during the compilation. We also have object file coming from the mylib.a library on the top right part of the slide. The linker takes the different object file from the different codes and from the library and merge them to make one executable. This kind of linking is called static. In the static linking, the machine code from library function is simply copied in the executable. Static libraries have extension .a on Linux and Mac OS, while they have extension .lib on Windows OS. To link a static library called libc in your code, we simply write gcc, the name of your source files, file1.c and file.c, -o, the name of the executable, and explicitly add first the flag --static and then the flag -al with the name of the library where the prefix lib is dropped. In this diagram, you can see machine code for file 1, file 2, and the library. By linking them at link time, you merge the three machine files, resulting in a machine code that is large as the combination of the three files. The second kind of library is dynamic, also called shared library. Differently from static linking, the programming libraries are not combined at link time. So in this slide, we had red cross between our library and the linker. Dynamic and shared libraries have extension .so in Linux and OS X system, while they have extension .dll on Windows system. How does a dynamic library work? When your library is linked against the shared library, only a small table is created in the executable. When the executable starts running, the operating system loads the machine code needed for the external function. This machine code is loaded at runtime and used whenever your source code is calling it. It is important to mention that there is no need to explicitly instruct the GCC compiler to do a dynamic link, as linking is by default dynamic. What are the advantages of using dynamic link? First, the final executable is more inside than the executable produced by static linking, because we are not copying anymore in the library code in the executable. Second, libraries can be upgraded and patched without the need of recompiling our source code, making a new executable. Disadvantages? We need to keep our libraries updated, as our code might necessitate a newer version of the library to run. Thank you.